All right, what's up, pre-cal students? We are working on the review. I'm doing this a little different. I'm actually going to drop two videos. This will be the first one. This one just because I actually don't have a lot of time here at lunch. So what I'm going to do is I'm going to do the ones that we weren't able to cover in class. That way, if that's all you need, like you're good with everything else, and that's all you need to get, then you're good to go. And then later today, hopefully by early afternoon, well, probably more like 3 or 4 today, I'll be able to drop a video doing the entire review, just in case you need some more clarification from the other stuff too. So let's get right to this stuff right here. Let's not waste any time. All right. So here's what we're doing. So we're solving for x. We need to use our properties to be able to go back and forth in solving for x here. One of the things that we can do, one of the strategies we can use is going between a logarithmic equation and changing it to an exponential. So like in this one, what I can do is I can change this from a logarithmic equation into an exponential. So that is 5 is the base, 3 is the exponent, and that's going to be equal to 5x. Okay, so that's one way that we can go about solving this exponential equation. From here, what we can do is we can say, all right, 5 to the third power is 125, and that equals 5x. Then we can divide by 5, and then we get x equals 25. Okay, pretty straightforward. Switching over, sometimes switching over from a logarithmic equation to an exponential can make it a lot more straightforward, make it a nice, easy linear equation that we can solve. Sometimes going the other way works too. Going from an exponential to a logarithmic makes things a lot easier for you as well. We'll do the same thing here. The base will be the base of my exponential. What it's equal to is the exponent, and then that's equal to x. So 4 to the 5th power would be equal to x. So let's check out that. 4 to the 5th power is 1024. I did not know that. 1024 equals x. Okay, so there's that one. All right. Sometimes you end up with ones like number 21. In this case, there is nothing I can raise 3 to, or at least nothing nice, to make 4.2. Okay. Also, making an exponential equation wouldn't help me much here. But what I can use is my change of base formula. So my change of base formula basically says I can change the base to whatever I want. And I'm going to change it to base 10 because that makes it easier to put in the calculator. And we'll put what was inside the operator on top. But then on bottom, this is just a formula. We'll go log of that new base, so base 10, and then what goes into the operator is what was my base originally. So that equals x. And this is definitely a calculator problem. So that's where I would actually be putting log of 4.2 and then dividing that by log of 3. Enter, and we'll do 3 decimal places, I guess. Doesn't specify, but we'll stick with that because we've been doing that most of this unit. So we'll stick with that. Okay? There we go. All right, we'll keep up with that kind of thing. This is, again, another exponential equation. This one would be advantageous for us to go ahead and change that to an exponential. So 9 would be my base. 3 halves would be my exponent, and that's equal to x. So 9 to the 3 halves. If you were to do that by hand, it'd be the square root of 9, which is 3. But then we still have that 3 there. And that equals x. 3 to the third power is 27, so x equals 27. Okay, you can also do this. 9 raised to the 3 halves is 27. Okay, this would be in the calculator section, so you could use that. Here's where we're going to go the opposite way. We have an exponential equation, but we want to switch it over to a logarithmic to be able to solve it, because I don't know how to turn 18 into base 6. Okay? So what I want to do is I want to change this to a logarithmic. So instead of going this way like we did over here, I actually want to change this to a logarithmic equation. So to do that, it's log base 6, because the bases have to match. Our exponent x goes to being what we're equal to. Okay? What we're equal to in the exponential goes into the operator, into the log operator. So this is log base 6 of 18 equals x. Okay? So that's what that turns into. Once we do that, we can use that change of base formula like we used in 21. So that would just be log base 10 of 18 divided by log base 10 of 6. And that would be equal to x. And then that is definitely a calculator portion there. So log of 18 divided by log, there it is, of 6. Okay. 1.613. 1.613 equals x. Okay? So there's that one. This one's really similar to the last one we did. The only thing is you have to be careful. We got to get rid of any coefficients that we've got going on with an exponential equation before we convert it to a logarithmic equation. So to do that, I'm going to divide by 3. Okay? So I'm going to divide by 3. So that's e to the x equals 5. Okay? Now I can convert this into a logarithmic equation. Remember, log base e is natural log. So if I do natural log of 5 equals x, that's one way of doing it. But if you need that extra step of checking out what I did, check it out. This is really log base e of 5 equals x. Okay? Log base e, remember, that's the same thing as natural log. So that's how I was able to jump from here to here. Okay? It's just log base e is natural log. So that's kind of the same thing. Okay? So I can do natural log of 5 right in the calculator. Natural log of 5. And then that would be 1.609 equals x. Alright? So there's that one. Okay, so that's like kind of converting back and forth. Our simple ones, our more complicated ones come from here on out. Okay? These ones we want to use some different properties, and we want to use those simplifying properties of logarithms. You know, we can condense them and we can convert them to, but this is one of the more important ones right here. When we have log base 4, so log of something base, we got log of the same base that are both equal to each other. Okay, there's only one on each side. Then what we want to do is we want to set the inside of those log operators equal to each other. So that's 3x minus 1 equals 2x plus 3. Just like that. Okay? So we can only do that if it's log base 4 on both sides. It's the only way we can do that. All right? If it wasn't a log base 4 over here, we'd have to use a different strategy. All right? Now we can just solve for x. So x is going to be equal to 4. Okay? It's just a simple linear equation on that one. All right? So, gotta have log base 4 on both sides. And there can only be one of them. Okay? There can only be one of them. Which brings me to number 26. Number 26, it's similar to 25. I got log base 3s on both sides of the equation, but there can only be one log operator on each side. This one I've got 2. So what I need to do is I need to use my properties of logarithms to actually put these two together. Okay, so I'm going to combine these two so there's only one first. So I'm going to leave that log base 3 of x alone over there. And then over here, my addition property for logarithms is that we multiply what's inside. So this is going to be log base 3 of 2 times 4, which is 8. Okay, now that I only have one log base 3 on each side, can I set these two equal to each other? So x equals 8. That was really easy. No simplifying needed on that one. Okay, so that one was, a little easier. Okay, so that's the strategy for ones where you got logs on both sides. 27 breaks that strategy. It breaks that mold. We need a completely different strategy for this one. Okay, notice before we even start, there's not log base 3s on both sides. So I cannot use the strategy that I did on these two. I can still condense these, and I still want to put these together using my simplifying rules. So when it's subtraction, we're going to divide what's on the inside. So that's going to be log base 3 of x over 2. Okay? And then that's going to be equal to 4. Okay? So what I did is I basically took x and I divided it by the 2. So still have that log operator there. There's not one on the other side. I can't say x over 2 equals 4. That's not what we're saying here. So we need a different strategy. My strategy for this one, if there's not logs on both sides, is to convert it to an exponential. My base is 3, okay? My exponent's 4, and then that has to be equal to what's on the inside of the operator, so x divided by 2. All right? Once I have that, I can do 3 to the 4th power. Don't remember that off the top of my head. Why does this die right when of course. Nope. Okay, let's try this one. Hey, there we go. All right, 3 to the 4th power is 81. Okay, that's what I thought. Just want to make sure. 81 equals x over 2. Solve for x by multiplying by 2. So that would be 2 times 81, 162, and that equals x. Okay, so if there's not logs on both sides, we have to convert to an exponential after we've condensed it down to 1. All right? Very similar thing happens in 28. There's not logs on both sides. So when I put these two together, this can be log base 4 of x minus 3 times x minus 3 equals 3. All right? I can simplify this a little bit. We can say log base 4 of x squared minus 6x plus 9. So foiling that out, that equals 3. Okay. Now I can do the same thing I did over here, where I can turn it into an exponential equation. 4 to the 3rd power equals x squared minus 6x plus 9. Okay, 4 to the 3rd power is 64. So that is 64. Let's get another piece of paper. So what happens when I do this during lunch? All right. Okay, so then we'll have 0 equals, or sorry, not 0, 64 equals x squared minus 6x plus 9. So I can subtract 64. Okay, 0 equals x squared minus 6x, and then that would be negative 55. Oh gosh, what is this? 0 equals, and then we'll have this. That would be x minus 11, x plus 6. So then that's x equals 11 and negative 6. Okay? So that was factoring here. What multiplies together to make negative 55? That adds together to make negative 6, negative 11, and 6. So that's why I came up with those ones. Solving for x on each one of those gives me positive 11 and negative 6. Okay? So there's that one on a separate sheet of paper. Okay. Last two here. These two are a mix. One, I've got logs equal to logs. The other one I don't. So 29 is logs equal to logs. Got to do some simplifying here. Okay? Remember, coefficients turn into exponents. So that's going to be log base 5 of x squared equals. And then when we're adding two logs together, we get 1 when we condense them together. And then we'll do 2 times 8. So we'll multiply the insides. We'll get 16. Okay, I got logs on both sides, which means I got my insides equal to each other. Solve, and I get x equals plus or minus 4. Remember, if you take the square root of both sides of an equation, you get two answers, plus or minus. Okay, all this stuff's coming together. All right, last one here. This is not like 29. 29 had logs on both sides. This is only on one side. So we got to make sure we condense. So we'll use our simplifying rules. We'll say x times x minus 6 equals 2. Okay, we can distribute this in there. It's log base 4 of x squared minus 6x equals 2. Okay, now, no log on the right side, so I cannot, absolutely cannot, set x squared minus 6x equal to 2. Okay, different strategy. Change it to an exponential. 4 squared equals x squared minus 6x. Okay, once I've got that, extra sheet of paper, 16 equals x squared minus 6x. Okay, let's see what happens here. So, 0 equals x squared minus 6x minus 16. So things that multiply together to make negative 16, that when I add are going to make negative 6. So how about negative 8 and positive 2? Okay, so that means that x equals 8 and negative 2. And there's my answer. Okay, again, this is just what we didn't cover in class. All right, so this is what we didn't cover in class. Later today, hopefully earlier rather than later, I'll be able to drop a video where I'll do the whole thing. Okay, maybe not the whole thing. Maybe just up to where I just ended. In case you missed class or something, Okay, so at least you got that. So there you go. All right. So be ready for the test. It's tomorrow. Again, this is the part where you'd have a calculator at your disposal. The stuff we did in class, remember that's going to be a calculator no-go option. So be ready for that. You'll have baby calculators, but there's that. All right. Good luck and happy studying.